Dear students, today in this video lecture, I will discuss about the compression. The compression is the function of the presentation layer of open system interconnection model, means OSI model. First of all, we define the compression definition. The compression like that data compression is a process of encoding data so that it takes less storage space or less transmission time that it would if it were not compressed. Data compression may be divided into two categories. Now, first data compression approach is lossless data compression and second is lossy data compression. According to lossless data compression refer to the compression where the exact input data value will be produced after decompression. While in lossy data compression, data may lose some of content and the exact information will not be reproduced after the decomposition. So basically compression are reduced number of bits and it compress by using two methods, lossless data compression and lossy data compression. The meaning of lossless, no data is lost after the decompression because exact data produced after the decompression. While in lossy data compression, data may lose some content and the exact information will not be reproduced after the decomposition. Now, discuss here some encoding method like that. Dictionary-based compression. The dictionary-based compression is divided into three categories: LZ77, LZ78, and LZW. So compression is code input data using coding technique in such way that the coded data take less amount of storage. For purpose, may coding technique are used. This process are called encoding. Encoding is therefore a part of compression. So dictionary-based compression method exploit the semantic of the data to reduce the redundancy of code. This method shows significant improvement of compression of character-based compression scheme. So basically, LZ77, LZ78, and LZW that are dictionary-based data compression algorithm. According to dictionary-based LZ77 compression method, in this method, first such buffer contain the part of input message being coded, and second main point of this method, look ahead upper contain forthcoming stream of character, and third very important, size of such buffer and look ahead upper remain the fixed, and fourth important part, look ahead upper to move over the input stream is in forward direction. So LZ77 scheme implements the dictionary in unique way. When input text is taken for compression, it start building the dictionary LZ77. The scheme was text window, which is divided into two parts. One contains the previously scanned text and other contained as an input text. For example, plain text are A, B, C, D, search buffer and look at buffer is denoted A, B, C, D, C, like that. And in this dictionary-based compression, we use the Huffman code algorithm. According to Huffman code algorithm, it provides different symbol and their frequency. Then we code the Huffman length with the help of Huffman coding. So we apply the Huffman code of the following example like that. If symbol is given A, B, C, D, E, F, and their frequency are given 40, 20, 15, 10, 10, 5. Then we apply the Huffman coding algorithm. First, we arrange the frequency in increasing order. I've given the example. So increase subset smallest frequency is F equal to 5. We write here 5, 10, 10, 15, 20, 40. We arrange the frequencies in increasing order. Now, according to Huffman code algorithm, select the first smallest node and combine them. So first smallest node 5 and 10, we combine these nodes the total weight is 15, and the rightmost children is weight is maximum, and leftmost children is minimum. Now again, we arrange the node according to increasing order. So first node is 10, next 15. 15 can any 15 first select, yeah, or this 15 can arrange in increasing order like that. After arranging these node, then we merge and combine first two smallest node and continue the process. We find the half main code tree after this. After finding this half main code, we coded the value in the left branch 0 and right branch 1, 0, 1, 0, 1, 0, 1. After coding of this value, we find the code value. A like that 1, B like that 0, 0, 0, C 1, 0, 0, yeah 0, 0, 1. So find out the code length, half main code length is 1, 3, 3, 3, 4, and 4. Now next we calculate the number of entropy and number of to frequency multiplied by the length. So here we find out the maximum frequency has minimum half main code length, and the smallest frequency have maximum half main code length. If we multiply the maximum frequency with the smallest length of code, we find number of bits is reduced, but with the help of half main code. Similarly, again, Shannon method are used for reducing or compress the encoding for data. Shannon algorithm reverse process of Hoffman algorithm, because here symbol are given, their frequency are given. The frequency are arranged in decreasing order instead of Hoffman code increasing order. After arranging these frequency, we calculate the Shannon number of Shannon length, number of bits. So division of this process like that, 60 is upper part and lower part 20, 15, and 5. So if lower sum of the lower part is equal to upper half, then division is feasible. Otherwise, division is not possible. So 60 is greater than the all sum of 20, 15, 5. So branch are divided, left side 60 and right side A, B, C, D, any 20, 15, 5. Now, next B division A, B, D in this branch. Now, first upper, assume the first upper part is 20 and lower part is 15 plus 5 is equal. So division is possible. So right part is 20 and left part is B, comma D, and 15 and 5. Now next, similarly divide the 15 and 5. Now denote the value 0, 1, 0, 1, 0, 1 and find the length of Shannon code. So C equal to 0, A equal to 1, 0, B equal to 1, 1, 0, and D equal to 1, 1. Length of C is 1 and frequency of C equal to 60. So maximum frequency contain the minimum length of code. So the second process of Shannon. Next dictionary method is LZ78. So this LZ78 represent the dictionary as a tree method. So the limitation of LZ78, because we calculate only limited number of words, because tree is very big size, so we cannot arrange this tree. So small, for smaller text we use the LZ78. The process of LZ78 like that. We maintain the table in the first step in, and second column is input phrase and third column is put the phrase. According to LZ78, we input the value of given text W and code 0, W. Means W is first starting character, therefore no precedence of W, so we write here 0, W. Similarly, y is the first time come. So the precedence of y equal to 0, 0, comma y, s0, comma s, star 0, comma x. Now, next character is w. W already is come. So next character we included with this w, then new character is wy. Now wy, put the phrase like w, the position of step equal to 1. So here, right here, 1 means step 1 are connected with y. Y are connected with step 1. G is the first time, so write here G0, 0W. Next, we write here W already come. Next, combine the character WY already come in the step 5. Now, next, combine the character SWY is the new character, new phrase. So, we can here write S is connected with the step 5, and 5, comma S. WY is the step 5, so we can write here 5, comma S. Similarly, next step W. Next step star W. Now star W, star is step 4. Right here star. So star comma W. Next YW 4 comma W and WYSC equal to 7 comma. After this phrase, we maintain the tree like that. For origin, started character of origin 0, W, Y, S, X, G, like that, W, Y, S, X, G. And right here their steps. After writing the steps, next Y are connected through 1. So 1 comma 5, 1 comma Y. Next 7 comma G, 7 comma S. Now maintain the dictionary tree with the help of LZ7. Now next method is the LZW algorithm. So overcome the limitation of LZ7 by LZW because tree is large. So arranging the tree is very difficult and complex. So we write here the process of LZW in the LZW. Similar process like that, input simple. Now create the output code from 0 set 255. Any code can be right here. And next, additional dictionary maintain from 255 above 256 to so on. Suppose that the first character of this given string is W. Suppose output code, any code right here, 0 to 255 like that, 63. And additional dictionary maintain W and next character of Y, WY equal to 256. Similarly, Y right here 65 and maintain that Y is equal to 257, yes equal to 59, S star equal to 258, star 15, star W equal to new stationary additional dictionary equal to 259. And next write W, W already is come. Next is character is Y, so WY is coded. WY is coded by 256. Here write WY. T is not T, has WY. So WY is coded by additional dictionary by 256. Then we write here the code 256. And next new dictionary WY comma WY is equal to 260. G equal to first time come 217. GW equal to 261. WY already come to 56. WY is equal to 262. S star and continue the process. We find the compression code output code like that 63, 65, 59, 15 to 56 and so on. This is the compression code of LZ7. So these LZ7, LZ7, 7, LZ7, 8, LZW are dictionary compression method. We reduce the number of bit of given. Right. Some audio and video compression are used in the data compression like that send audio or video over the internet require compression. So in this section, we discuss audio compression first and then video compression. So audio compression and video compression like that. Some compression, JPEG compression are used per picture. This is lossy compression because after the decompression of the file, some text is lost. So JPG compression means joint picture expert group are used the following steps. In the first step of JPG, use the DCT. This second step, quantization, and step third, use data compression. Or the third stage, we find the compressed image. So in the first step description like that, discrete cosine transfer, the image in the form of block of 8 cross 8 equal to 64 pixel is applied to DCT box, and each 8 cross 8 block will undergo the transformation called discrete cosine transfer DCT. Now the next step second, use the quantization. The quantization means the transformed 8 cross 8 block are in the quantize. The process of quantization reduce the number of bit required to the base required to be used for encoding. So quantization is the process of approximation. Therefore, we lose some information and it's not possible to recover this information at all. Now step third of JPG compression. In the first step, use DCT and transform table T is created. After the quantization, the value in the table are read to remove redundant 0 bits. So table read zigzag manner to produce the compressed image. So like figure, so the figure number of block contain the image like that 8 cross 8 pixel blocks. These block images are processed 3 phase of JPG, TCD, quantization, data compression. After the process of 3 steps, we find the compressed image like that. And uniform grayscale like that picture are converted like that pixel coordinate of PXY and find out in form of TM, N. So 2 sections are pictures. PXI like that, black and green, then find out TM, N in this form. And case 3, gradient grayscale like that picture this, then we calculate it like this. And reading the table like that in zigzag manner, 20, 15, 15, this is zigzag manner, and find the result like that, 20, 15, 15, so on. This is the process of JPG compression. Similarly, we use the MPG moving picture expert group compression. MPG is another standard moving picture expert group. This algorithm of standardized to compress moving pictures, and digital motion video can be accomplished with the JPG still image standard if you have fast enough hardware to process 30 images per second. However, the maximum compression potential cannot be achieved because the redundancy between frame is not being exploited. So MPG frame like moving picture expert group frame like that, IBBPPI that, like that, this is frame are formed in this manner. Means 1 P and B, PBBI are and frame are constructed and construction of frame like that. This process used for the moving compressor of moving picture expert group. So is the brief introduction about JPG MPG compression. Thank you. Next lecture discuss about different type of application.